Welcome back to the fifth lesson in the Unity Game Dev tutorial series for beginners. In the previous lesson, I introduced you to Unity's physics system. We use this to add a force on a game object and thereby make it move. But the Unity physics system can control even more things. In this lesson, I introduce a part called collision detection. It is possible to detect when a game object touches another game object. This is, for example, very useful to detect when you cross the finish line in a racing game. But before we get started with collision detection, I first want to introduce you to a new data type. We want to be able to keep track of whether something is true or not. For this, we have the Bool variable at our disposal. This is a special data type that can only contain two values, true or false. Let's briefly return to sending messages to the console. Using debug.log statements, this is the easiest way to explain the Bool data type. We add a 3D game object to the hierarchy. Then we'll link a script, called test, to this game object. Open the test script. Let's see what message appears in the console. When we create a debug.log statement with the value 2 is less than 1. In the console, the message false appears. That corresponds to what I learned at school. 2 is not less than 1. So the statement is indeed false. What can we do with this? Well, we can attach the value to a Bool variable. We declare a Bool variable called isGrounded. We add the value 2 is less than 1 to this grounded variable. We send isGrounded to the console using debug.log. And again false appears in the console. We can also directly give the value true or false to this grounded variable. We can move the variable isGrounded to the top of the class and make it visible in the Unity editor by making it public. Because a Bool can only be true or false, a public Bool variable is displayed in the editor as a checkbox. So you can check it to set it to true, or you can uncheck it to set it to false. A Bool variable is very useful to make your script execute something when a certain condition arises. We want to keep an eye on the Bool variable, and if its value changes to true, then execute some code. We can make a statement with the if keyword, and then immediately after it between parentheses the Bool that we want to test if it is true. Between the curly brackets we can place the code that should be executed if the value is true. Let's add a debug.log statement to test if it works. The message, player is grounded, appears in the console. This is because the Bool variable contains the value true. If we set the Bool variable to false, then we will not see the message appear in the console. That's what we could expect. But whether it is because the value is false, or because we made a mistake, we do not see the difference now. You also want to see a response if the value is false. We can do this in different ways. The first way is to place an exclamation point in front of the Bool variable. The exclamation mark reverses the value. True becomes false, and false becomes true. Very useful in this case. The second way is to use a double equals symbol. A single equals symbol means assign the following value to this variable. A double equals checks whether the value on the left is equal to the value on the right. This results in true or false. The third way I show is by applying an if-else statement. This indicates do this if the bool variable is true, otherwise do this. Now a separate message will appear in the console, whether the value is true or false. In Lesson 2, we created a function called SumUp. To call this function you must enter the name, followed by parentheses. With the help of the parentheses, you can pass in a value to the function when you call it. The function must be created for this purpose. Let's create our own function that accepts an input value. First, I want to clear the script before the console is flooded with messages. We start by creating a function as we did before, type void, the name of the function, and double parentheses followed by curly brackets. Between the curly brackets we can place the statement that is run when the function gets called. So far nothing new. Where the function is created, we indicate between brackets which data type the function accepts variables from. We also give these input values a name, which we can use inside the curly brackets to work with. In this example, our function accepts two int values named a and b. Between the curly brackets, we declare a local int variable called sum. We use this variable to add the two int variables together. We send the value of the local variable sum to the console. Now when calling the function, we can pass in two int variables, separated by a comma, between the parentheses. The first value we pass in is 2, and the second value is 4. The result should be the value 6 appearing in the console. Let's pick up where we left off in Lesson 4. We have a sphere that we can control through user input. We can jump with the space bar, but we can also jump when the player is in the air. And when in the air we can steer the sphere, not very realistic. We want to give the player the ability to jump and control only when touching the ground. Now it looks like the player has a jetpack. We want to build something into our script that allows us to check whether or not the player hits the ground. You guessed it, that sounds like we need to use a bool variable. We start by declaring a public bool variable called isGrounded. We immediately give this the value false. Now let's finally start with the collision detection. If you start by typing OnCollision, the autocomplete will quickly find the correct function. We look for OnCollisionEnter. As you can see, this is a function that accepts an input value, in this case of the collision data type. This allows us to place a conditional statement within the curly brackets. In other words, we can use if to test whether a game object to which this script is attached is making contact with the ground. In the if statement we test whether the name of the game object that collides with the player is equal to plane. In our case, the ground on which the player rests after being pulled down by gravity is called plane. And then to test whether this works, we place a debug.log statement between the curly brackets. If we have done it correctly, the message will appear in the console from the moment the sphere touches the plane. We can now change the value of this grounded variable to true if the collision is detected. We now have a function that detects when a collision occurs, but we also need a function that detects when the collision ends. We also have the function OnCollisionExit that does just that. It needs little explanation because it is quite similar to OnCollisionEnter. We just need to change the message of the debug.log statement and change the variable is grounded to false. Now, we see a message appear when the sphere hits the plane, and we also see a message appear when the sphere leaves the plane. Now in the fixed update function, we can make the add force for movement and jumping situation dependent using an if statement. We check if is grounded is true. Only if that is the case will the movement and jumping be run in fixed update. The consequence of only being able to jump when grounded is true is that you only rise a very small amount when you jump. When we create a public float variable jump force and multiply it by the vector 3 jump, we can adjust the jump height. It's difficult to show, but when you jump you can no longer steer in the air. You can adjust the jump force if you want to jump even less high. Please like and subscribe so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development. Thanks for watching. In the next lesson we'll learn about camera movement, how to follow a player,